Hello, this is Scholar Strive doing some math today. In Algebra 2, we'll be looking at the counting principle and permutations. So, near the end of Chapter 2, usually we teach basically a little bit of statistics and a little bit of trig, so you can decide as a student whether or not you want to take a statistics course for your next math, basically we're introducing you to statistics and trig, because usually the next step would either be pre-calculus or AP statistics. So if you find any of this interesting, you may want to take a statistics course or go into statistics. So here we go. Fundamental counting principle. If one event can occur in m ways, another event can occur in n ways, and the number of ways that both events can occur is m times n. This can extend for more than... We could extend this for more events. 3 plus events. M times n times p times z, or times dot 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 times z times however many letters that we need. So here's an example. You're framing a picture. The frames come in 12 different styles. Number of styles, 12 different styles. Each style is available in 55 different colors. And if you want a mat for the picture, I'm not familiar with a mat on a frame, but if you wanted a mat for the picture, it's available in 11 different colors. So how many ways can you frame this picture? So you would take the number of styles times the number of different colors times the number of mat options. Now I have to read this carefully because we could technically not want a mat, but it says you always want a mat. Okay, so we have to take it. So we just do 12 times 55 times 11. So the number of possible ways to frame this picture is 7,260 ways. Let's look at license plates. So the standard configuration for an Oregon license plate is 3 digits followed by 3 letters. How many different license plates are possible if letters and digits can be repeated? So we have 3 numbers and 3 letters. Okay. So for numbers, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is 10 possible ways for the first digit, and then 10 possible ways for the second digit, and 10 possible ways for the third digit. And then we have letters, and assuming they just mean the 26 letters in our alphabet, this is how we would find the number of possible license plates. We would just multiply everything together here. 10 times 10 times 10 times 26 times 26 times 26 is equal to 17,576,000 different ways, or, well, different license plates if you can repeat letters and digits. Now, if they can't be repeated, so for example, if we put, so we have 10 possible choices for the first digit, and since it can't repeat, that means like if I chose 5, I can no longer choose 5. That means there would be 9 possible choices left. And then after that, there would be 8 possible choices left. And then with the letters, 26 choices for the first, then 25, then 24. Multiply all this, and of course there's less. 11,232,000 license plates. You flip a coin, then roll a 6-sided die, and then pick a card from a standard 52-card deck. How many different sets of outcomes are there? So I could flip a coin. It can land on heads or tails. So we have a coin. There's 2 possible outcomes. There's heads or tails. A die is, well, they say 6-sided dice. So there's 6 sides, 6 possible. So 2 times 6, and then 52 cards in a deck. And even though they have like 4 aces, 4 ones, 4 twos, they're all different suits. So there's actually 52 different cards in a deck. So that would be 624 outcomes. So I could roll heads, a number 3 on the dice, and draw a 6 of clubs. Or I could roll the same heads and the same number 3 on the dice, but have the same 6, but of hearts instead of clubs. And those would be 2 different outcomes. So permutations is the ordering of an object. So for example, if I wanted to find the permutations of the letters A, B, and C, I could start off with ordering them as A, B, C, or I can change it to A, C, B. I could start with B and do B, A, C, or B, C, A, or I can start with C, A, B, C, B, A. And these are all my permutations. So to help us, we're going to learn about factorial. And if you haven't learned about this before, factorial means you take the number and you multiply it by the previous number all the way until you get down to 1. Times dot 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 times 3 times 2 times 1. So how would that look like if we just use a number here? So 6 factorial is equal to, so 6 exclamation point, or 6 factorial, start off with 6 times the number before that, times the number previously, then 3, then 2, then 1. And that equals the 720. We're going to denote, though, that 0 factorial is equal to 1. So, how we see permutations, if we wanted to take permutations of something, we'll see it look like being denoted like this. NPR. which is equal to n factorial over n minus r factorial. So let's look at an example. 10 skiers are competing in a race. In how many different ways can the teams finish, assuming that there are no ties? And let's change teams into skiers, because there's 10 individual skiers. So how we would find is this would be 10 so we're choosing out of the 10 skiers, we want to arrange them in 10 different slots. So in this case, n and r are both 10. Taking the 10 skiers, that's the left number, and sorting them into 10 positions, which would be r. So this would be equal to n factorial, which is 10 factorial over 10 minus 10 factorial, which means this would be 10 factorial over 1, which would be 10 times 9 times 8 times 7 times 6 times 5 times ... times 3 times 2 times... well, actually, I can just do the whole thing, which is equal to 3,628,800 ways. Part 2 of this problem: in how many ways can gold, bronze, and silver medals be awarded for first, second, and third place finishers, assuming that there are no ties? So out of the 10 skiers, we're going to see how many ways we can put them into just the first 3 positions. First, second, and third place. Gold, silver, and bronze. So that would be 10 factorial over 10 minus 3 factorial, which is 10 factorial over 7 factorial. So what do we do here? So remember, 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. We can change it into 10 times 9 times 8 times 7 factorial, and then on the bottom we have 7 factorial. Those will cancel, and we're left with 10 times 9 times 8, which is 720 ways you can arrange 10 participants, first, second, and third. Part G, there is a raffle at the school carnival. There are 50 tickets in the raffle, and 4 raffle tickets will be selected for 4 unique prizes. How many different ways can the 4 winning tickets be selected? So out of the 50 raffle tickets, we're going to choose 4 of them for winning. So 50 over 50 minus 4, which is 50 times 49 times 48 times 47 times 46 factorial over 46 factorial. Cancel. And we're left with 5,527,200. Permutations with repetition. Okay, so this is, so before we've been working with permutations without repetition, which means once you take one, it can't be chosen again. So like with the 10 different skiers, the person that comes in first place can't also come in last place. Now we're going to do permutations with repetition. and that is equal to n explanation or factorial over s1 factorial, s2 factorial, s3 factorial, and so on. So let's take a look at this here. If you don't notice, this I, the first E is in bold. So I'm going to use probably a different color for that, but let's say we wanted to see all the different permutations of I here and I over there. So we could have EYE. All right, let's EYE. This is what I'll do, yeah. I'll have the bold E be capital, and we'll have the regular E be lowercase. So we have EYE, so I'll just erase this. And I have, no, actually, yeah, I'll just use colors. So, YE, YE, okay, let's just make this red. So we can have an E here, we can have an E there, or we can have an E there. So there would be 6 permutations here. Versus if you want to look at the different permutations of this guy, we would only have EYE, EEY, and YEE. All right. So there's the difference between with and without repetition. So here we go, part K. Find the number of distinguishable permutations of the letters in the following words: Miami, Tallahassee, and Hannah. So Miami, there's 5 letters. And for the first letter M, that shows up twice. So 2, and I shows up twice. And the rest of the letters, A, you don't have to worry about this, but that would be 1 factorial. And yeah, for the last letter A, it would be 1 factorial. So that would change into 5 factorial, which is 120. And there is a function on your calculator to do that. And 2 times 2 is 4. So once again, this is the number of M's that you have, the number of I's that you have, and the number of A's that you have. So there's 30 different ways you can do Miami. Tallahassee, there is 11 letters here. 2 L's. So there's 1 T, there's 2 L's, there's 3 A's. So I'm just skipping the T because it's just 1 factorial. There's one H, there's two E's, and two S's. So we would get 39,916,800 divided by 6 times 2 times 2 times 2, whatever that is, becomes 831,600. And then Hannah, we have 1, 2, 3, 4, 6 letters, and H can be done twice, A can be done, or A shows up twice, and N shows up twice. So this is 720 divided by 2 times 2 times 2, which is 8. So 90. And that's all I have for you today. Have a good one.